Welcome, class. Today's lesson is called Graphing Systems of Equations. A system of equations when you graph more than one line. So that's how the definition reads. Two or more linear equations involving the same variables form a system of equations. So a solution to the system of equation is an ordered pair. It's the point where the lines cross. That means that point will satisfy both equations. If you plug that point into both equations, it would come out equal. So here's your different types of systems of equations. You can have intersecting lines, which is the most common. That means there's exactly one solution, so one ordered pair. And it's called consistent and independent. This is something else you'll need to know. That's what you call it. They're consistent and they're independent. The next one is if the two equations become the same line, they're on top of each other. This means they have infinitely many solutions, and they're called consistent and dependent. And then the third case is they end up being parallel lines. Of course, that means no solution. They don't ever cross, and they're called inconsistent. So now that we have learned that, we're going to use that table to evaluate some lines here. So our first one, we're going to look at these two lines on the graph to the right. Negative 3x plus 1 is going to be right here. And then 3x plus 1 is right here. So it's the red line and the looks like a blue line or light blue line. They cross right here. They cross at one point. So we're going to use this graph to determine whether they are consistent or inconsistent, or if they're independent or dependent. So look back at our chart. If they cross at one line, they have exactly one solution. So they're called consistent and independent. Now, we'll do it again. Before we can find these two lines, let's put the bottom one in a slope-intercept form. So when we bring our x over, we'll subtract x. So we'll have negative y equals negative x plus, or I'm sorry, minus 3. It'll be plus 3 here in a second. Negative x minus 3. Then when we get rid of our negative in front of the y by dividing by negative 1, we'll get y equals positive x plus 3. And then when you end up with this, and you look back at the first one, they're the same line. They absolutely match. So our answer here, when it's the same line, will be consistent and dependent. So we'll say consistent and dependent. Of course, I'm running into my letters. All right, last one. Look for y equals x minus 3. It's the green line. And then y equals x plus 3 is the, looks like dark blue or purple line. It's hard to tell. And when we look at these two, they're parallel. They're never going to cross. So we're going to call this one inconsistent. There's no solutions. So you'll use your chart and you can go off that, and that's what you're going to use in your assignment. All right, let's look at the next part of your assignment. You're going to graph, of course, graph a couple of lines and determine the number of solutions they have. If it has one solution, we're going to name it. In other words, we'll name the point. So let's start by graphing this line. So we'll go up positive 6 on our y, or our y-intercept. Then we'll apply our slope, which is up 6 and over 1. And I'm going to go down because I can't go up 6. 2, 3, 4, 5, 6. And left 1, because this is a positive slope, so I'll have to do 2 negative moves. Then we'll go down 6 again and left 1. So this line has an extremely steep slope on it. Draw our line. Now we'll graph the second one. Again, positive 6 is where we start. it has a slope of 3. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And so on. And you can see this one, of course my line's not perfectly straight, but obviously the point it intersects is the y-intercept. You can see that just by looking at the equation. So our solution is that point, which is 0, 6, because we have to name the point. It's up the y-axis at 6, so it's 0, 6, and that's where they intersect. Now let's do this again. The next set. I'm going to bring my board up just a little bit. Move my problems around so that I have room to work this one out. Because we're going to have to set both of these into slope-intercept form first. We'll take the 8x minus 4y equals 16. We will subtract 8x first, so we'll get negative 4y equals negative 8x plus 16. Then we'll divide by negative 4. Y equals a positive 2x and a negative 4. So here's our first line. So we'll go over here, go down 4, put a dot, that's our starting point. Then we'll go up 2 over 1, up 2 over 1. And that's how we'll graph our line. Or we'll go down 2 and left 1, because it is a positive slope. And we're drawing our line. Next, let's do the second line. Negative 5x minus 5y equals 5. So we'll add 5x. So you get negative 5y equals positive 5x plus 5. We have to divide by negative 5. We'll end up with y equals negative x minus 1. Go to our graph, negative 1. Here's our starting point. We have a negative slope, so if you go up, you must go left 1, like this. Or if you go down, you'll go right 1. And there is our solution, because we just intersected that line. So go ahead and draw your line right through it. And then we're going to name our solution, which is this point here where they cross. And it is at 1, negative 2. So the solution to this is not negative 1, sorry. 1 over 1 down 2. And there's our solution. That's the answer to that system of equations. That's how it works. Let's go see if we can do a couple more here. Real quick, in case you need to see more examples. So we're going to use this top one first. Put the first one into slope-intercept form. We'll start out with subtracting 4x. So we'll get negative 6y equals negative 4x plus 12. Divide by negative 6. We get y equals a positive. We're going to simplify 4 over 6 to be 2/3 x, and then a subtract 2. And we're going to do the next one. Negative 2x plus 3y equals negative 6. Switch my marker. Add 2x first. So we'll get 3y equals 2x minus 6. Then we'll divide by 3. We'll end up with y equals 2/3 x minus 2. Now, before we go graph these, look at your two equations. They're exactly the same, so it's the same line. So the answer is infinitely many solutions, because they go on forever in both directions. So they have an infinite number of solutions. They're on the top of each other. There's your answer to that one. Now, we're going to try this equation, this set of equations as our last example. So first one is 2x plus 3y equals 10. We'll subtract our 2x. we're putting this in slope-intercept form, negative 2x plus 10, divide by 3. We're going to end up with y equals negative 2/3 x, just leave it as a fraction, plus, and we'll leave this as a fraction, 10 over 3. That doesn't simplify it, just leave it like that. Then let's do the second one now. 4x plus 6y equals 12. Subtract our 4x, get 6y equals negative 4x plus 12. Divide by 6. We'll end up with y equals a negative, simplify your slope, 2/3 x, and then plus 2. Now in this situation, it's good to rewrite these in slope-intercept form before you graph them, because it may save you some time. But when we look at them, we have the same slope, if you'll notice. But the y-intercept is different. When this happens, these are parallel lines. These are not the same line because the y-intercept is different. But the slope is identical, so this means they're never going to cross. So there is no solution to this set of equations. And there's your answer in that situation. So those are the 3 types you can get: is a no solution, infinitely many, or an actual point where they do cross. I'll see you in class.